All right, solving formulas for a specified variable is really just means that you're going to have a formula that you're going to have to isolate. So one of the things you really want to do is to read it. So we talked about a lot before, reading what it says. What are the math operations? Does it say multiply? Does it say divide? Are there several steps involved in order to do this? Rewrite the formula. That just means that you want to get the variable that you're solving for perhaps all the way over to the left, like when we worked with other equations in StatMep, because you want to make sure you're working with all the other pieces first and then solving it. Solving is not really what you're going to do. You're going to isolate a variable. That just means get it by itself. So when you talk about solving, you're not getting an answer. You're getting the formula rewritten. Sometimes the formulas are pretty easy. I did not look up what this one means, but G equals I divided by H. Sounds pretty good to me. I don't need to rewrite anything. And it says that I want to solve it for H, or isolate H. So here's what I want to get all by itself. That means I got to get rid of the I. The I is dividing, so I'm going to multiply it to the other side. G times I equals H, and that's it. It's solved for H. Many times you have a lot of pieces to it. So this is the volume of a sphere. So volume V equals 4/3 pi times radius cubed. We want to solve this for R. So the pieces that I need to remove is this 4/3 times pi and also the cube. So remember, working through StatMep, this would be a multiply problem, and this is your exponent all the way at the end. So I'm going to work through this one. The only thing I want to rewrite on this one is I put that fraction into the whole problem. So 4 times pi times r cubed is all divided by 3 is what this says. 4/3 of all of this stuff. So when I rewrite it, now I understand how to isolate that r. First I'm going to remove the 3. Then I'm going to remove the 4 pi. 4 times pi is like one big number. If you think about what 4 times pi is, it's 12 point something. So that's what I'm going to get rid of next. And then finally I'll remove that exponent. So when I multiply by 3, divide by the 4 pi, this whole thing is going to become a cube root. So again, this is what it's going to look like. I'm going to have the cube root of 4 times 3. Oops, there should be a 4 in there. My mistake. I'm going to divide by that 4 pi. And that would be r. So if I calculate this thing now with PEMDAS, 4 times volume, whatever the volume of my sphere is, times by 3, divide it by 4 times pi, you can make that a decimal value, and then cube root my answer. And that would give me the radius of my sphere, or a ball. The next one is length equals pi times radius 1 plus radius 2 plus 2 times diameter. And this one I want to solve for D. I'm going to get D all by itself. D is over here, and as far as I'm concerned, that looks pretty good. I don't think I'm going to need to rewrite it because I'm going to work with this part first. Now in isolating D, this is really just some great big thing, number, added to 2D. So I'm going to subtract through StatMep first. I'm going to subtract this whole giant ridiculous thing off. So when I do that, it's just that thing subtracted from L. Now remember, we never want to distribute, so I'm just going to leave this like this. If I distribute the pi, that's fine. I would distribute it maybe if I were going to evaluate this, but probably not. So I'm going to subtract that thing away, and then I have to get the 2 off of the 2D, so that means divide everything by 2. So it's this big thing, L minus whatever that is, all divided by 2, and that's it. Keeping the same formula again, what if I wanted to isolate one of these radii, radius 1 or radius 2? So this one says I want to get radius 1. So think about what we did before. This 2D is added to this thing. So right now I want to keep this where it is. So this is like, I'm going to do this. I didn't choose to rewrite it. You could flip-flop these two together so that the 2D is near the L and working through SADMEP and backwards and opposite. So length, L, minus 2D equals pi times this thing. I need to remove the pi, so I'm going to divide it over. And now the one that I want to get all alone is R1. So I'm going to subtract R2 over. And finally, this is my final formula where I have solved or isolated for R sub 1. Length minus 2 times diameter, divide that by pi, and then subtract the second radius off. I know that these sound pretty strange, but a lot of times what you're trying to do is just isolate it because you're always working to find that radius 1. Or maybe you're always working to isolate the diameter of something. This way, all I'm going to do is put this in my calculator, and with a little bit of work, I can tell my calculator how to do this properly in order of operations. As you work through these practice problems, just recall and look back at what we did in the examples. I will post a solution to this later this week.